Hello and welcome to my presentation on the topic of drugs and diseases as a part of neurobiology with a focus on synaptic transmission and on the example of nicotine. I hope you enjoy. Beginning with the table of contents and what I'll be talking about within this presentation, we start out with the general information, naturally, with the properties, synonyms, history and development, as well as usage of nicotine. Then we'll move on to the molecular side of the matter, such as its absorption into the organism, the molecular side in the brain, the effects on the brain, and next up we talk about one of the main effects nicotine has, namely its dependence. So we'll talk about key numbers with reference to other recreational drugs, the tolerance theories that surround the dependence, and of course addiction, a topic that we cannot avoid when talking about nicotine. And lastly, we'll end up with the health risks for tobacco and tobacco's physiological effects, one of which, an important one, is cancer and the chemical damage to the body. Yes, so the general properties of nicotine are namely that, first of all, it's a natural derivative of a plant of the nightshade family, tobacco. Also, it's a stimulant, meaning that it's a drug that increases the activity of a nervous system. Another example of that would, for example, be caffeine, or if you take the illegal route, cocaine. Its chemical properties also include that it's an alkaloid, meaning that, as you can see in the middle, the chemical structure includes a nitrogenous organic compound that has physiological effects on the absorbent organism. Furthermore, it's also a toxic substance. It's a toxic chemical substance. That means that it can damage the organism. Synonyms, such as different trade names, include Nicorette, Nicotril, and Habitur, and many more, depending on, for example, the company that sells them. And an interesting fact to say about nicotine is that its formal name is, or the plant's formal name is Nicotiana tabacum, and tobacco, that's natural, but Nicotiana is derived from the French ambassador Jean Nicot, who was the first person that brought the plant to Paris. And talking about history and its development, we begin at America, or native indigenous America, northern as well as southern, where tobacco has been used as, for example, a ritual substance for different traditions, or for its medical use for centuries. Therefore, it's indigenous to America, the American continent. Then colonization happened, and tobacco arrived in Europe around the 16th century, either from British or French and so on and so forth, and there it spread. It's important to say that at first people did not find out the use for it as a recreational drug. In the beginning, they thought it was either a poison or medicine, but the research was not developed enough that it was used as a recreational drug, as opposed to later on, of course. The isolation of the chemical compound took place in the early 19th century, so around 1828. The chemical compound was isolated by German scientists Posselt and Reinmann, and from then on, this sparked further scientific research into nicotine, and many more scientific discoveries were made afterwards. And with that, in the late 19th century, we also saw mass production because of the industrialization, and of course mass consumption. In the next 100 years and more, we would see a dramatic spike in its use as one of the most prevalent recreational drugs. I mean, you cannot, even if you take media, for example, you cannot take a contemporary piece of media, for example, of the early 20th century, without people smoking every second scene. I mean, you can see that if you know, for example, the show on Netflix, Peaky Blinders. I would bet there is not a single scene where one of the characters isn't smoking on screen. And it's important to say also that limitations and its idea as a drug, its categorization as a drug, did not take place until later on because of the developing medical research and so on. It was just accepted as a day-to-day consumptive matter. Limitations, for example, in the US took place in the 90s, so 1994. The Food and Drug Administration categorized it first as a drug, almost, over 100 years after the mass production. We move on to its usage, which I already talked about. It's heavily addictive and widely propagated recreational drug, meaning that it's not used for medical reasons. And ironically, its second most prevalent usage is the smoking cessation, a nicotine therapy through, for example, patches or tablets, pills, to lessen withdrawal symptoms arising from addiction. A less common use is of nicotine as a pesticide, because it is an anti-herbivore chemical, but that is not that much propagated because there are way cheaper and way less harmful alternatives for pesticides. Now, coming to the physical effects of nicotine, we come to the absorption, how it actually gets into the body, into the system, into the brain. Nicotine can be absorbed through mucosal linings in the nose, mouth, and lungs, so through inhalation, the gastrointestinal tract, and the skin. The most efficient way of that is through the lungs, because of the tiny air sacs called alveoli that provide an enormous surface area through which nicotine is absorbed and then travels into the bloodstream and into the brain. Also, in the lungs, it's transferred or broken down to nicotine oxide. Moving on, through the gastrointestinal tract and the skin, that's a way for non-smoking tobacco consumption, for example, chewing tobacco and nicotine patches. And once absorbed, enzymes in the liver break down about 80% of nicotine, so a high absorption rate, and it's turned into metabolite nicotinine, from which on it goes into the bloodstream again and into the brain, into the central nervous system. And on average, it only takes 10 seconds for it to get into the brain and show activity, which is a very short, absorption time, 10 seconds. Now, moving on to the molecular side. Nicotine is considered an agonist at the nicotinic acetylcholine receptors of the presynaptic neurons or the sending neurons. So as you can see here in the picture, on the upper side we have a nicotine receptor, where, for example, a acetylcholine receptor would have been. So nicotine from the bloodstream in the central nervous system binds to this ligand-gated receptor, which makes the vesicles of the presynaptic neuron with the neurotransmitters inside of them move and merge with the presynaptic membrane here, and so a neurotransmitter is released, and in this case dopamine is released. And you might know that dopamine is a hormone or a neurotransmitter that causes happy feelings, pleasure feelings of that, and here it binds to the receiving neuron, the dopamine receptors, which are also ligand gated. So the receiving neuron passes on this wave of happiness, as you can say. And also, here we see the depolarization and action. The depolarization when it goes out. Along the concentration gradient, the dopamine flows out into the synaptic cleft, where it causes afterwards a depolarization at the postsynaptic membrane. That causes an action potential at the receiving neuron, which is then passed on to the other one, so it spreads. Yes, synaptic transmission. And this causes important neurochemical effects. So we have this concept, the so-called reward pathway in the brain, starting by nicotine entering the brain, and the stimulation of the nicotine receptors I just talked about. There it goes first to the VTA, the ventral tegmental area. the nucleus accumbens and the prefrontal cortex. I won't be talking too much about it, but this is basically the dopamine reward pathway. And normally this reward pathway is necessary for survival. It sends you reward feelings or pleasurable feelings when you do something that is necessary for your survival. For example, if you work out, there's dopamine release. If you eat, there's dopamine release. And once it's inhibited by nicotine, and there is this unregulated form of reward and the reward system, this causes long-lasting issues in the brain because it associates, the nicotine consumption with this massive outflow of dopamine and happy feelings. And down there you see the neurotransmitters and their effects, and most of them are pleasure, arousal, appetite suppression. I'll talk about it in a minute, don't worry, but important ones are dopamine, I talked about, norepinephrine, which is also, I believe, a painkiller. And an interesting thing is also that it actually inhibits and suppresses neurotransmitters such as glutamate and GABA that are there for the regulation of dopamine, for example. That means it not only triggers this happiness and arousal, but it also inhibits the actual molecules that should inhibit this arousal and happiness. So it's totally unregulated. That's why it's so important. And here we have a quote from Dr. McGee, which I thought was very adequately summarized the entire issue. The combination of effects, increasing dopamine release and decreasing inhibitory response, results in an amplification of the rewarding properties of nicotine. It would be difficult to design a better drug to promote addiction. And because of the neurochemical effects it has, it is such a perfect drug. And the nicotine's effects on the brain, as you could have seen in before with the neurochemical effects, it's stress relief, it alleviates anxiety, depression, pain, it promotes pleasure, it increases focus, and it's an appetite suppressant, all of which are effects that are generally desirable, but they all come with their disadvantages, as we'll see in a minute. Coming to dependence, the morbid side of nicotine consumptions. We see 1 billion people, an estimated amount of 1 billion people smoke worldwide, and it has the third highest dependence potential. It's only topped by heroin and cocaine, and this is truly scary as it is a mostly legal substance, and as we can see, 1 billion, that's widely propagated. And the 31.9% capture rate is a rate that says that, I believe, 31.9% of people that have tried it once are likely to use again. Another interesting thing is that there were scientific studies that show that children are more susceptible to nicotine addiction because their underdeveloped prefrontal cortex, which is a part of the reward pathway, is more susceptible to addiction. That's also a interesting thing to say. And studies, although they're not hold to that much scientific value as of now, they have shown that women are more susceptible with different scientific validity. So it's not known if that is a causation or correlation or anything. I just thought it was interesting. And over 80% of the world's 1 billion tobacco users live in low-income and middle-income countries. And this would be interesting if you take nicotine as a social issue. Moving on to different tolerance theories. It's actually not completely known scientifically, or at least nothing I could understand, why one becomes tolerant after a while. One theory is that receptors become less responsive because of the use of nicotine. So you need more nicotine to trigger the receptors to trigger the efflux of dopamine, if you can follow. The other main theory is that there are just simply less receptors. They somehow get damaged or removed by the nicotine use or worn out, so there are less receptors in numbers, and thus you need more and more constant influx of nicotine to keep the same dopamine levels in your body afloat. And the scary thing about dependence and addiction is also the withdrawal. You get intense cravings for nicotine, irritability, anxiety, anger, in general, a less stable mental health overall. There are also physical repercussions such as weight gain, insomnia, nausea, and headache because of these cravings. And the brain actually has an interesting reason for these withdrawals. So as you can see in the diagram on the right, if you, for example, let's say, for the sake of the argument, let's say you smoke every day at 6 p.m. You smoke one cigarette. After a while, your brain becomes accustomed to the fact that you will smoke a cigarette at 6 p.m. So your brain beforehand will do a sort of correction. So it anticipates these positive feelings, the efflux of dopamine. So in prevention, your brain corrects it by sending out hormones that should cancel out the dopamine, meaning that they send out your brain sends out hormones and other molecules that make you feel less happy and more anxious and less concentrated. So we have this brain correction that wants to remain in homeostasis because it anticipates the cigarette. But once you do not take the 6 p.m. cigarette and nicotine intake, your brain still corrects it because it's used to it. So you do not have the compensating effect of the nicotine, you just have the brain's correction, which leads to those negative feelings and withdrawal symptoms. Another shocking number: 8 million people die every year in relation to tobacco use. And this is a surprisingly high effect rate also for secondhand smokers, which also includes pregnancy, so smoking while pregnancy. And a large proportion of that could be subscribed to infant death because of pregnancy smoking. And it's alluded to that 10,000 people of those 8 million are only from secondhand smoking. It's also said that for every death, 30 live with serious smoking-related illnesses. So this is a small fraction of the awful consequences tobacco uses. And you notice that I'm saying smoking-related and tobacco use. That is because, I'll talk about it in a second, tobacco is the very damaging part of the nicotine, because basically nicotine invites you in and makes you addicted, and tobacco destroys your body. Some of tobacco's effects are pulmonary, meaning that toxins deposit in the lungs. Carcinogens, it causes cancer, and endothelial, so inflammation at the inner linings of the arteries, and other endothelial causes cause heart attacks and strokes. And on the left hand side you can see the various different health risks. There are, for example, diabetes, tuberculosis, eye disease, immune system repercussions, rheumatoid arthritis, gum disease, hearing loss, fertility problems, osteoporosis. Basically, almost for every disease you can think of, you could blame cigarette use or as a contribution to it. Because imagine, a cigarette has over 4,000 toxic chemicals in it. Those are a lot of toxic chemicals, if you ask me. Here you can see a diagram from the CDC that showcases the different kinds of cancers that can be caused by these carcinogens found in cigarettes. Almost every single part of your body could be affected by these carcinogens. Moving on to the chemical damage in a more microscopic way, so to say. Nicotine narrows veins and arteries. It also damages the heart by working faster and faster. It slows the blood pressure and blood flow and reduces oxygen flow to the hands and feet. That is why extremities are often cold and deficient in oxygen. Moving on to carbon monoxide, the airways actually swell up and let less air into the lungs. So this also deprives the heart of oxygen and leads to these endothelial problems. We have tar, which is a sticky substance that sticks to lungs like soot to a chimney, which coats the lungs and further causes pulmonary issues. We have the phenols that kill hair-like cells in the airways, and these hair-like cells normally clean the linings of your airways, so you become more accustomed to you get pulmonary infections more easily because you don't have that added protection from the hair-like cells in the airways. We have the minor particles that produce more mucus and damage the lung tissues, which leads to an irritated airway and damaged lung tissues, as I said. And that's also one of the main causes of the famous smoker's cough. That is mostly why smokers cough after extensive nicotine use. We also have ammonia and formaldehyde that irritate the eyes, nose, and throat and can propagate illnesses. And lastly, the ones I mentioned before, the carcinogens that promote this abnormal cell growth that can culminate in a higher probability for cancer. Now, coming to the social factors and this addiction factor. 70% want to quit, 50% try to quit, and only 5% quit successfully. These are relative numbers. These are not representative of every single smoking inhabitant on the earth, but it's a relative representation of the effect it has on this psychological dependencies. Not only on the physical dependencies, but the most important part of most addictions is the psychological dependency. And there are many ways people try to quit, for example, cold turkey, giving up nicotine at all, or these nicotine therapies I mentioned at the start. And imagine only 5% quit successfully. And the others, and even those who have successfully quit, have to live with the repercussions and the consequences of smoking. So thank you for the attention. I wanted to give credits for the template for the presentation to SlidesGo, a site I really like using. And this entire presentation could also be seen as a big smoking campaign. Don't smoke, kids. Here is my bibliography. You can screenshot it and read it up for yourself. And I hope you found it to some extent helpful and, yes, useful. Thank you for listening. Thank you for your attention, and I hope you have a nice day.